Welcome to the first lesson in JavaScript 201. We are going to first start off with something fairly easy but also very important. We're going to be talking about style guide or cleanly writing your code. And so there's a lot of different ways we can write JavaScript because it doesn't really care about extra white space. It doesn't really care about a lot of different things. Now, that is sometimes a good thing. That is sometimes a bad thing. It really truly depends on who's writing the JavaScript. And when it comes down to writing clean JavaScript, there are some tips and tricks that I can give you, but typically, just because, again, it doesn't care about white space, it doesn't care about extra spacing too much, it's really up to you. So there is no one standard fits all. There are some opinionated ways to write JavaScript, but I'm going to show you just a typical clean way that's going to get you 90% there. So let's go ahead and open up our editor. I'm just using VS Code here, and I'm going to change this over from plain text to JavaScript. And in here, typically when we have a var, a let, or a const, we can do something like const var name is equal to thing. And so typically what we're doing here is we're assigning var, let, or const, typically just let or const because that's the modern JavaScript way of doing it. Then we use camel casing. So we use a naming method with variables that the first word, the first identifiable word is lowercase, and then the second identifiable word is uppercase. So if I was to type, my name is Caleb, this is how I would typically name a variable. Now, if you're working with a more global const, and you'll see this in production level JavaScript, you'd see something like const name uppercase is equal to Caleb. Typically, we still use semicolons, although sometimes we don't. Sometimes we use a transpiler or a compiler to automatically add semicolons for us, but it doesn't hurt to have it in there. So a const like this, because we know that a const is a constant, it's not ever changed, that means we can put it in uppercase. And so down the road, we can say something like console.log name. And we know that this is going to be a constant just because it's all uppercase. But if we saw console.log, my name is Caleb, we would know that this is a variable. Now moving on, we have conditionals. There's a few different ways to do this. Some people like spaces, some people don't like spaces. Typically we do if brackets, something is equal to something else. So we're comparing a variable to a hard-coded value, or we're comparing a variable to another variable, brackets, and then we have our code in here. And this is typically how we write our code. So you'll see some people do like this, and then they'll have it all sort of on one line. That's not going to work with a code comment. Like this just looks really, really poor. It's hard to read. You want your code to be nice and legible, nice and readable. So we say if, and then brackets, or sometimes there's a space there. If something is equal to something, then some other code. Else, we put that in the same line as this closing bracket here. Something else in here. Now, when it comes down to functions, functions are very, very similar. We do something like function, the name of the function. We use same type of variable casing here. So we use camel casing. The function, parameter 1, parameter 2, and it looks the exact same. And so then we put our code in here. And so we have keyword, the function name, parameters with a nice little space in there, and then opening and closing curly braces with our code inside. And then we could put if statements, we could put consts in there, we could do all sorts of things. And so again, I see a lot of people writing code like this. And if you only have a one-line function, this is probably okay. But if you have multi-line functions, feel free to use extra space. So for instance, coming back to the top here, I've seen people do this. Const my name is Caleb is equal to thing. Const name is equal to Caleb. I've seen this before. You don't want that. And actually, because this first one here is actually not a constant, we're going to use let. But I've seen people use multiple assignment operators like this in one line, and there's a better way to do it. And honestly, just use a little extra space, but keep it nice and close together. And again, the idea here is that down the road, someone else is going to look at your code and be able to read it nice and easily. It's really important that your code is legible. As an intermediate JavaScript developer, You can't write code anymore that looks like a mess. It might be very readable to you, but it might not be readable for other people. And you always want to make sure your code is readable. And why that's important is because when your code is nice and readable, that means your code is maintainable. That means you can work together with other people on a team. Now, there's this thing called the Airbnb standard, and they have a specific way of doing this. There's also, what is it called? Prettier. You can do auto formatting as well, and it will apply its opinions automatically to your JavaScript. And that one is just called Prettier. We're not going to cover that in this course, just because it's a little too opinionated for this particular course, but you might see something like that, and it'll take your ugly JavaScript and it will format it to be something like this. It'll even add semicolons or remove semicolons depending on your rules. It'll do all sorts of stuff for you. But until you get to that point, it's good practice to make sure that you are always writing good, healthy, clean, readable JavaScript. Because these scripts can get really long. They can be thousands of lines long. They could be hundreds of lines long. Even then, that gets pretty big. And you want to make sure that it's very easy to have someone else read your code. So that, you know, when someone else works with your code down the road, when you get a job as a web developer, that they don't hate you. That is the primary motivation here, is that you don't want them to hate you. So you want them to be able to open up your code and be like, hey, this is nice, clean code. Maybe they don't agree with 100% of it. Maybe they don't like the space. Whatever. That's a minor thing. But as long as they can read it easily, that's the important thing. So moving forward, make sure that you are writing clean JavaScript down the road. Waiting for the page to load. All right, we have a way here. Actually, there's a couple different ways, but we have a way here to make sure that everything on our page is loaded before we execute our JavaScript. And now the reason I do that, or the reason we're talking about that, is because if I change this to HTML, and in here we can do HTML5, we have body, and this could be all sorts of HTML. Let's say this is 10,000 lines of HTML, and at the very bottom, you have your script tag, where your script should live, at the bottom of all of your HTML. Well, it's got to render about 10,000 lines of code, maybe more, maybe less, but it's got to render all of that before it can execute your script. Now, sometimes browsers are too fast, and that means it's going to try to render everything, but while it's rendering it in the background, it's also going to execute your JavaScript, and occasionally, your JavaScript is going to execute and try to find an element in your document object model inside of your HTML, and it's not going to exist yet. It might have been loaded in like the source code, but your browser just hasn't processed it yet. It hasn't really understood how to make sense of it yet. And so the idea is we wait until all of that is loaded, and then we can execute our JavaScript. And we can do that with window.onLoad, and you can see this is auto filling for me. That's pretty nice. Is equal to some sort of function. And I'm just going to give this an anonymous function and do a thing. So we could say alert page is loaded. So I'm going to save this as index.html in a folder called JavaScript 201. And if I go over to my browser and just go File, Open, and open up index.html, we're going to see this page is loaded. So it actually doesn't even look like it's loaded, but it is. At this point, as soon as I hit OK, my page is going to turn white. Everything is loading perfectly fine. And this just means, hey, everything has loaded. It's perfect. And so when the page finally loads, this is what you're going to see. Now, if you wanted to write proper JavaScript, which we're not going to do moving forward just because it's a little extra overhead for every lesson and it's probably a little overkill for you after this video, but we would ideally write all of our JavaScript in here. And again, that just means that our entire body is loaded. Now, if you're working with 1 or 2 lines of HTML, or maybe even 100 lines of HTML, this may never come into effect. You may never be able to reproduce that sort of problem I was talking about earlier. But if you have 10,000 lines of JavaScript, 10,000 lines of HTML, that might take a little more processing. If your HTML is super nested, like if you've ever looked at the source code for Facebook, it's super nested because it uses react.js. And sometimes that takes a little longer to process. And the idea there is you wait for all of that to be processed, and then you work with your JavaScript. What I would like you to do is give this a shot. Write window.onLoad is equal to an anonymous function, and then just write an alert or a console log or something like that just to make sure that it's working for you. Once you're done that, let's head on over to the next lesson where we learn about the opposite. Window, basically offload. When we are done with a page and we're about to move away from it, what happens? In this lesson, let's take a look at what happens when you are about to close a page. And so you've probably edited like a post on Facebook or some other social media site, or you've been going to write a post rather, and you don't save it, you don't post it, and you close the browser, you close the tab, and this little window pops up and says, are you sure? Do you actually want to leave? That is using window on before unload, and we're going to talk about that in this lesson. So it looks like window dot on before unload, and just like the last lesson, this takes an anonymous function, and in here we can say, alert, you are leaving the page. And at this point, we can actually prevent them from leaving the page. We can give them a prompt, but in this case, I just want to say you are leaving the page. And so let's go ahead and give this a shot. And now this is not going to do exactly what we expect it to do. And so I'm just going to open this up in a new tab, and we're going to see that this takes a little extra work. And so let's just open up our console just for good measure, and let's try to reload the page. We're going to see that nothing happens. In fact, occasionally we get this little red arrow at the bottom there, and if I keep refreshing this fast enough, it says blocked alert, you were leaving the page before unload. Okay, so that's actually exactly what I wanted to show you. This does not work. You can't just say alert, you were leaving the page. What you have to do is, well, you can do some sort of non-intrusive interaction. So you can write some JavaScript. So before unload, and we're just going to console log that. And let's throw a semicolon at the end there. That's not always needed. Sometimes I forget them, sometimes I don't. And let's also return. Let's say return, are you sure you want to leave? Now this message may not actually be rendered depending on your version of the browser. Browsers used to fully support a custom message like this. Lately, they just don't. That might change in the future, that might not, who knows. But all we're going to do is have a return statement there. And so I'm going to refresh the page, and now I've got the new code in here. I can view my source. We do have the new code in there. Close that and hit refresh, and it says reload site, changes you made may not have been saved. Okay, I can cancel, it's not going to do anything, it says before unload. I can do it again, click reload, and it reloads my page, and you can see my console also refreshed as well. So where this comes in really useful or really handy is, let's say you made a video player and you wanted to track people's progress. And so when they come back to the video, that, maybe they're 30 seconds in, you can start that video at 30 seconds. And this is how you do that. Before unload, and then you would do a little AJAX request over to your server saying, oh, the user is at 30 seconds, or create a cookie and say that they're at 30 seconds on this particular video. Then you can ask them if you want to leave. That gives them enough time to confirm. It gives your code enough time to make an AJAX call to your server or something like that. And then either they can leave, or maybe it's a mistake. Maybe they were writing a Facebook post or something, and they actually didn't want to leave. They didn't want to lose their work. This is where it comes in really useful. So what I would like you to do here is do window.on before unload is equal to an anonymous function, console log something, and then return really anything. It doesn't have to say, are you sure you want to leave? It could literally say anything. Make sure you close that function, go to your page, and when you load it up, just hit refresh. And you should see this reload site. Or if you're on Firefox, it's going to look a little different. If you're on Safari, it might look a little bit different. Just give this a shot and make sure that it works for you. This is a really useful feature to know how it works. Let's take a look at strict comparison. You're going to see this a lot in JavaScript, modern JavaScript rather. So typically we have some sort of variable is equal to some sort of value, and then we have our code in here. What you're going to see a lot more often these days than just two equal signs, and this is a loose comparison, is you're going to see three equal signs. And so this triple equals will do the same comparison as a double equals, but without the type conversion. And so let's just head on over to our browser and we'll do a live example. So I'm in my browser and I'm going to open up my console here. And I'm going to say, let num is equal to the number 0, but it's a string. It's not a number, it's a string. So if we do type of num, we're going to see that this is a string. And we should already know about strings and numbers and objects and things like that. If you don't, this would be a good time to take a little refresh and go back to JavaScript 101. This is really important for JavaScript 201. So we have a number here. It is set to the string of 0. if we did console.log num is equal to 0, we're going to see that this is true. We could also do is equal to 0, and this is also going to be true. So we're comparing a string, so number is a string, comparing it to a string, and the value, that's true. Obviously, that's the exact same value. This one here is number, again, string up here, is equal to 0. That's a number. So this one is a string, this one is a number type. They happen to have the same value, 0, but this one is a number, and this one up here is a string. So this is really important to know the difference. What happens if we do a strict comparison? A strict comparison is going to check to see if this, which is a string, and this is also a string, and also has the same value. So they have to be literally identical. And this is actually significantly faster for processing. So you're going to see this a lot in normal JavaScript these days. And this is going to turn out to be false. So everything else was true, but this one is false because this, again, is a lot like saying, and maybe I can change this. So this was a lot like saying 0 is that the same as 0? No, because 1 is a string, 1 is a number. This is also the same as saying, is a string equal to a number? These are technically different things. For instance, you can make a string uppercase, but you can't make a number uppercase. Numbers are already basically uppercase 24/7, so you can't do certain things, and you can't perform certain math on strings. Like if I put my name as Caleb, you won't be able to multiply that by 907 divided by 4 to the exponent of 2. Whereas a number, you could do that quite easily. And so that's a strict comparison. And so again, it's going to check to see if the left side is the same value and the same type of variable, the same data type as the one on the right. And this is faster for processing. So in the future, whenever you see 3 equal signs, just know that it's comparing string is equal to string or number is equal to number plus the value is equal to value. Whereas the loose one up here is saying, okay, well, even if this number is 0, if it's a string or a number, it doesn't really matter as long as it's the same. And so it's a loose comparison. Strict comparisons are faster for processing, and you're going to see these in the future and in production level code. What I would like you to do is give this a shot. Do this exact example. Set number is equal to 0 as a string, do type of, console log it. Num is equal to 0 as a string, num is equal to 0 as a number, and then do a strict comparison. We can even do the exact same here, or console log num is equal to 0, and this is going to be true because this is actually 0. If we go up here, you can see it even has quotations around it. We compared it to be the exact same thing. So this now returns true. And now you could say if num is equal to 0, do something else. That's more of a conditional comparison thing. We're not going to worry too much about that, but the big takeaway here is that there is a difference between comparing a string and a number or an object and an array. There are differences in data structures, these data types, and so it's good to know that you can compare those along with the value as well. Scope is where variables are allowed to live. For example, when you declare a let or a const, it really only lives within its closest set of curly braces, and we learned that in JavaScript 101 as well. Now, as a refresher, if you have some sort of function, and you say let var name is equal to something, this let cannot exist outside here. Outside. This let is scoped to these curly braces. Const does the same thing too, and I'm saying const. So let and const do the same thing. This is where we get into scope, because things are interesting. Especially in the world of JavaScript. Things are very interesting in the world of JavaScript. So if we declare a var here, it's still going to be scoped to these curly braces. And that's just because it's using function as a scope. So it's trying to encapsulate, it's trying to hold everything inside of this function. Now, if we have an if statement, that's different. Code sort of passes through an if statement a little bit more, whereas a function tries to put all of your code in a box and move it aside and say, encapsulate, hold everything in here. Don't really consider too much outside. Don't let the pet escape the kennel kind of thing. Whereas if we said, let's create a number here, const num is equal to 1, 2, 3, 4. If num, strict comparison, 1, 2, 3, 4. const greeting is equal to hello 1234. Just something basic. So this const is accessible in here because it was declared outside of these curly braces. This const greeting is not accessible outside of here because it was declared within these curly braces. And so if you ever see a variable that says it's undeclared or doesn't exist, if you're using let or const, chances are it's just being scoped to its closest set of curly braces. This is really important to know. var sort of works the same way, but we don't see var too much in production style or production level JavaScript anymore. We see let and const for the most part. And so the idea here is know when things are being scoped. Again, this just means greeting can only live inside of here. We have to work with this particular variable inside here. Same thing would happen if we used let instead of const. Exact same concept. Now, if we used var, this is where it gets different. If we said var greeting, we could use console.log var. And that's because var is not scoped to its closest set of curly braces. Const and let is, for sure, but var is not. var is allowed to break through these. And it's a little more fluid. It allows the variable, or it allows your program to sort of come through from the top to the bottom. And even if there was another variable called greeting, it would execute that, and then it would say, perform some sort of logic. And if there's another var in here, instead of a let or a const, if there's another var in here, it just says, okay, pick that up as well, and make it accessible later. Whereas in this example here, it's going to read from top to bottom, so it's going to assign num is equal to 1234, strict comparison, num is equal to 1234, const is equal to greeting, and it says, oh, okay, well, this is a const, scope it to its closest set of curly braces, and this greeting here is not going to be accessible in here. So what I would like you to do is trial this out and get a little bit of experience with this. In fact, write this exact code out by hand. And I want you to start writing code out by hand instead of just copying and pasting, because there is a difference in skill level when people actually write things out and get a little bit of muscle memory and experience things firsthand, versus just taking my code and changing a little bit here and there. So write this out. This is a small example. It should only take about a minute or two. We're going to use a strict comparison. That's important. Set a const or a let in here. So const or a let. And then try to access that variable name outside of those curly braces, and you should see an error. Once you've done that, let's go ahead and talk about hoisting. Hoisting lets you declare a variable using the var, let, or const keywords without giving it a value. And this is a unique thing to JavaScript. And so what I'm saying here is you can actually define a variable, name is equal to something. This is how we've typically been doing it. But we could also just say var name. And this is just going to set name is equal to undefined. It doesn't know if it's going to be a number. It doesn't know if it's going to be a string. It doesn't know if it's going to be an object, an array, anything. It's going to be undefined. Now, what's interesting about JavaScript is we could say, you know, a bunch of code in here. Let's pretend I'm writing JavaScript. I have no idea what this is going to autofill, but let's pretend that's JavaScript, okay? And then we have var name is equal to Caleb. That's me. What this is going to do is say, don't actually assign this. What it's going to do is bump this up. It's going to grab that, and it's going to move it to the very top of its scope. And so if that's in a function, it's going to move it to the top of a function. If it's in your window, which is what we see here, the global scope, the window, it's going to move it to the very top. And so it's not going to actually do anything. It's just going to say, hey, at some point in time, there's going to be a variable called name, but currently it's undefined. And then we're going to do some JavaScript, and then we're going to define it. So as an example here, what we can do is we can say before and after console.log name, console.log the name. We're going to console.log the name first, and then second. And so what we're going to see here is this is going to be undefined. It's going to say first undefined, and then it's going to say name, second name. So let's go ahead and save that. Let's go over to our browser and open up our console. Let's just clear this. And let's refresh the page. And it says first, nothing. Second, Caleb. And so if we did this, if we just got rid of this, if we commented out as if it doesn't exist, we're going to see, well, now we've got caching in place. But if we do name2, it says name2 is not defined. And all I did there was just change from name to name2. That was just a caching thing. My browser's trying to be too smart for its own good and say, oh, name was already defined at some point, use name2. So at this point, with this commented out, we get an uncaught reference error. Name2 is not defined. That means this variable does not exist. But when we do this, Caleb Tallien, or let's do my Twitter handle, @CalebTallien. When we refresh, we're going to see the first one is undefined again, and the second one is @CalebTallien. And again, all that's doing here is saying, oh, there's a variable name2. Actually move that to the top. Say var name2. But don't actually assign it to anything. So it's still going to be undefined. That's its type. It's undefined. It's not a string. It's not an integer. It's not a number. It's not a anything. It's just undefined. It's just a piece of memory that's going to be allocated in your computer. And so this is undefined. That's why we saw first undefined. Then we defined it with a string. And second shows up as second with a string of @CalebTallien. So that's what hoisting does. Whenever you use varlet or const, it just bumps it up to the very top of its scope. Again, if that's in a function, that's going to be the top of the function, not the top of your script, but the top of your function. Now, why is that important? Well, that means at some point in time, if I declare a variable in the wrong spot, I can still access it. It's not going to give me an uncaught reference error telling me that name2 is not defined. It's going to instead move it up to the top and define it as undefined. It's going to set it as undefined. So you're not going to get error does not exist. Instead, you're going to get error does exist. There's just nothing in it. JavaScript doesn't know what it's going to be yet. So that is hoisting, and that is a relatively unique thing to JavaScript. A lot of people disagree with it. A lot of people like it. Personally, I don't think it matters that much because really you're not going to run into it too often unless you're writing some very, very clever code. And for the most part, we try not to be too clever with our code. We try to just keep it nice and simple and maintainable and readable. Go ahead and give this a shot. Do console log and then log a variable and then set that variable. It could be let, const, or var. It doesn't really matter. Set it on the second line, and then on the third line, console log that variable again. You're going to see undefined and then your value in there. When you're done that, let's talk about closures, which is a way of accessing variables from outside of a scope. A closure gives you access to an outer function's scope. For instance, you can write a function inside of a function if you wanted to, or you can access a variable from outside of that function without actually explicitly passing it in. So we could say function greeting console.log hello, and then whatever someone's name is going to be. So let's actually change this to a template literal, and let's say hello name, or let's do hello person1, whoever person1 is going to be. Now, this is not going to work for us because A, it's not being instantiated, it's not being executed, so we have to actually run this particular function, but it's also not going to work because person1 is not defined. So let's go ahead and run this, and let's just see what happens. Let's go back to our browser, and I'm just leaving off from the last lesson. I'm going to refresh here, and it says uncaught reference error, person1 is not defined. And again, we just know that this variable doesn't exist. And so what we can do is we could say person1 is a parameter in here, and in here we could say Caleb. And what this is going to do is say hello Caleb. So I go back, refresh, it says hello Caleb. Nothing fancy, that's a pretty standard function at this point. But if we didn't want to pass that in, we could indirectly pass in a variable. Let's say const, not const, let's do let. Let person1 is equal to Caleb M. Tallien. That's my name. And what this is going to do, because of a closure, it says let can exist outside of here, which also means it's accessible in here. And so this is now going to say hello Caleb M. Tallien. So let's get rid of this. There is no function parameter anymore, and you should be somewhat familiar with functions at this point. There's no function parameter, so we're not actually passing in person1. This is getting inherited by the code outside of the function. So let's go ahead, save, and refresh. And it says, hello, Caleb M. Tallien, just as expected. This is called a closure. This means that you can write code outside of a function and have it accessible inside of a function. Now, what doesn't work is inside of this function, we could say var person2, and we're going to use var because it has no scoping to our closest curly braces here, so we're not using let or const, we're using var. Person2 is going to be John. And down here we could say console.log person2 is the second person. And we're going to see that this actually doesn't work for us. So let's refresh. And hello Caleb M. Tallene works. That's because it's going through here. It says person1. Here's a function. We defined a variable in here. Greeting. We executed that function. And then we tried to console log this variable. And now this gets into scoping as well. This var is scoped to this function. It means it's not accessible. When you create a variable inside of a function, you can't access it from outside of that function. But the reverse is true. You can create a function, or you can create a variable outside of a function and access it inside of the function. That's a closure in JavaScript. Now, what I would like you to do is give this a shot so that you understand it a little bit better, because this is used all over the place. And this is actually one of the things that makes JavaScript really messy, is because you can have a really long JavaScript file and not know where person1 is coming from. Maybe it's even coming from like an API, for instance, and you don't necessarily know where that data is coming from. That can get really, really tricky. So it's good to know about closures, because if you're reading this function, and let's say you don't have access to this or this, you're thinking, well, where is person1 coming from? And it's really important to know that closures exist. Person1 is coming from outside of this function. So I'm just going to undo that. And I want you to give this a shot. Feel free to write this out exactly as I have it as well and experiment with it. So define a variable on the outside of the function, create a function, console log that variable name, and then execute that particular function. Step 2 would be create a variable inside of your function and try to console log it outside of the function and watch that it doesn't work. It gives you a reference error. Person2 is not going to be defined. Go ahead and give that a shot. When you are ready, I'll see you in the next video. And let's just say do a thing. Let's name that properly. Do a thing. And it's going to do some sort of thing. But when this function is run every single time, should it do another thing? And what we can do now is take our large code. So let's say we have 50 lines of code inside of this function. Just pretend there's 50 lines in here. And it's doing two major things. And the first thing has to happen before the second thing. So let's say maybe it's going to set a variable name called name is equal to Caleb. Name is equal to Caleb. And then it does some processing. It says, if the name is Caleb, you are an admin. Show a link to your website admin. Then it's going to do a second thing. What we can actually do is break this into a separate function and call it as a callback. And what that means, a callback, really is going to do one thing and then it's going to do another thing. And so a good example here is, instead of getting into functions, which we can write our own callbacks, but that might be a little bit much at this point, we can use set timeout. And this is going to take a function, and we'll talk more about set timeout in the future, but this is going to take a function, just an anonymous function, and let's make it wait 2,500 milliseconds, or 2.5 seconds. And so what this is doing is this is going to create a set timeout, or a timeout. And so it's immediately going to wait 2.5 seconds. That's its primary function. That's the first thing it's going to do. It's going to wait 2.5 seconds. And then it's going to do this thing in here. So let's console log this. Console.log waiting 2.5 seconds. And then it's going to wait that 2.5 seconds because this is our callback. It's a function to execute after the primary function. And then it's going to execute this. So let's save that. And let's just refresh the page. And we're going to see wait 2.5 seconds and then do this thing in here. That shows up after 2.5 seconds. Again, I just clicked refresh and it just waits exactly 2.5 seconds, or 2,500 milliseconds. And so that's a callback. And so you're going to see these all over the place in JavaScript. They're very, very important, but they can also be really confusing because a callback can have a callback, can have a callback, can have a callback. And it can just keep going and going and going, which gets really, really confusing. We're only going to go one layer deep and use one callback. So what I would like you to do is try the setTimeout function. Set timeout, give it an anonymous function, console log or alert or do something in there. It could do really anything. And then give it a wait time in. So it's just comma and then the wait time in milliseconds. And so what this is going to do is say, hey, I know that there's code in here. It's going to read that code, but it's going to hold on to it for 2.5 seconds. After 2.5 seconds passes, it's then going to execute this code. Now let's go ahead and see what happens here when we do console.log, and this is just a fun little experiment. The last line. And so we have got console log, wait 2.5 seconds. It's going to execute this, and then it's going to execute this. But because this is an event-driven language and we're using a callback, technically this has been executed already. So it's going to execute this line, then it's going to execute these, and then it's going to execute this. However, this is going to wait 2.5 seconds. After 2.5 seconds, it's going to run this. So if we understand this correctly, we're going to see wait 2.5 seconds, the last line, do this thing in here. And when I refresh my page, it says wait 2.5 seconds, the last line, then after 2.5 seconds, do this thing in here. And so that's not to say that this wasn't executed on time. It actually was. It was just told, hey, execute this, but hold that in memory for 2.5 seconds, and then execute it. So it goes this line, then this line, then this line, then this line, then this line, top to bottom, like it normally does. It's just there was a callback to say, wait for a little bit. And I would like you to give this a shot as well. So console log something at the beginning, set timeout, console log something at the end so you can get a little bit of hands-on experience with it, and do something in the middle with a timeout. When you're done that, let's move on to the next lesson where we use strict mode. Strict mode makes writing your JavaScript more secure and strict. Basically, you cannot blindly set variables. You must use them with var, const, or let. So when you use strict mode, something like x is equal to thing, this just simply will not work. Now, strict mode is the preferred way to write code because it's strict. It's not going to allow certain problems to happen. And as an example, we can enable strict mode by using use strict as a string at the very top of our script. You can also use this inside of a function. So if you want all of your code to be loosely written, you can do that. And then inside of a function, it can be strict. Typically, you see this at the beginning of a script, and it just becomes global. And because this is a string, this works on older versions of Internet Explorer, for instance, or Edge, or Chrome, or browser, or Firefox browser, or anything like that. Because if it doesn't support use strict, well, it does support strings. So there we go. All modern browsers will support use strict though. So what we can do here is say use strict, and then let's go ahead and say x is equal to thing. Let's save this and refresh our page here, and we're going to see an uncaught reference error. X is not defined. Although we did actually define it. It's just saying that it needs to know if it's going to be a var, let, or const. So if we said let x is equal to thing, it works for us. If we say const is equal to thing, no errors, that means it's working. Var even works the same way. But if we get rid of it, we see uncaught reference error, x is not defined. Let's go ahead and comment out use strict, and we're going to see that this all of a sudden works. We don't see any errors, we know that it's working. So at this point in time, it's pretty safe to say if we don't see errors, we're doing something right. Or we have a typo. Now this is the nice thing about use strict. Is let's say we have a variable called let is equal to x, and then we have some sort of custom logic down here, and it's doing something with x, and then all of a sudden it says x is equal to something else. And let's console log this, console.log x. We refresh our page and it says something else. That's perfect. Let's say we accidentally typoed x. And this was, instead of x, this was z. And typos happen all the time. This is a very common thing in programming. And so we accidentally said z is something else. Let's go ahead and save this, refresh our page. We're going to see an uncaught reference error. Z is not defined. Now, if we turn off use strict, what this is going to do is say, let x is equal to thing, and this is also going to define a new variable. Now, if this variable happens to be storing a lot of information, that can be very memory heavy on your computer and slow down your website. it might cause a problem. You might be trying to access a variable called x, or change a variable called x, but you accidentally typoed it to z because they're side by side on, at least on my keyboard, they're side by side. And so now you have two variables in here. So I can refresh and it says thing. If I type x, thing, and z is also something else. Now with useStrict, it prevents us from making little typos like this because we would have to properly redeclare it as let z. So let's go ahead and save this and refresh. And we're going to see, yeah, exactly, uncaught reference error, z is not defined. And that's because this is simply a typo. Now if we change this back to x, life is going to be good. It's not going to complain. We are now using stricter code. This is just one way to benefit from using useStrict. Now, moving forward, I personally would prefer if you used useStrict all the time. It just makes your code a little nicer, a little easier to manage, and you won't run into unnecessary bugs. And most importantly, as you're just learning, you're not going to run into typos, because typos happen. I've been doing this for 20 years. I've been on a computer for 25 years, and I still make typos all the time. It's part of being on a computer. useStrict helps us prevent that from happening. Go ahead and give this exact code a shot. Let's just clean this up a little bit. Type useStrict at the very top, assign a variable like let x is equal to thing, and then z without let, const, or var in front of it, just an empty variable, just define it this way, is equal to something else. You don't even need the console log in there. This alone will throw an error for you. And then go ahead and disable useStrict. When you disable useStrict, you're going to see that all of a sudden this is acceptable. But without useStrict, it's not acceptable. Go ahead and give that a shot when you are ready. I'll meet you over in the next video. Let's take a look at timeouts and intervals. These are two ways of writing particular code that will do something either repeatedly or it will wait to do something. So we've actually already seen set timeout. And this is a function that takes another function as a callback, and then some timeout time. So we can say wait 3 seconds, and this is 3 seconds in milliseconds, so this is 3,000 milliseconds. We just write 3,000, and then we could say console.log waiting, or not waiting, it waited already, waited 3 seconds. And we could say up here console.log starting script. And if we go back to our browser and refresh, it's going to say starting script is going to wait that 3 seconds, and then it says waited 3 seconds. Now this in particular is using a callback. No, not that one, this one is using a callback. So we're saying set timeout has a function of a callback function. It's going to then wait that 3 seconds and execute this code. And that's good. That does exactly what we want it to do. Now there's another one. I'm just going to comment this out because that's currently not needed. There's another one called set timeout. And so if I make some extra room to work here, we have not set timeout, set interval. And again, this is going to take a function. That's a callback function. And how often should this run? So let's say this should run every 2 seconds or 2,000 milliseconds. Console.log checking something. Maybe it's making an API request. Maybe it's checking to see if a variable is set. Maybe it's checking to see if someone's moved around on the page. We don't know yet. Could be literally anything. The important thing here is that we're going to execute this code every 2 seconds. So let's go ahead, save that, and refresh here. And I'm going to refresh, and it's going to wait 2 seconds, and then there it is. Wait another 2 seconds. There it is. Wait another 2 seconds. There it is. It's going to keep going and going and going. Now, we can also remove this interval. So let's say we wanted this to only execute 3 times. So we could say let count is equal to 0, and then after every interval, let's do count plus plus. And then let's say if that count is equal to strict comparison, so we're using strictly numbers here, 3, then unset the interval. And let's also console log that. Console.log, that was the last one. And now we're just missing the unset the interval part. And so we can actually declare this as a variable as well, which is really nice because in JavaScript, a lot of things are objects. And so we can set this function with a callback function basically as a variable. And so we could say const interval is equal to set this interval with the callback function. Do this every 2 seconds. Every time it runs, it's going to increase that count. So it's going to run once, count 1, run twice, count twice, or 2. Run a third time, count 3. And then when it says that count is equal to 3, let's unset this. And so we could do clear interval, and this takes a variable name, interval. And so this matches this, interval and interval. I know we're using this word a lot, but this one is the variable. And in fact, we can actually even change this here. So interval, we could change this to my interval. Let's go ahead and save this. And you can see this is still running from last time we looked at the browser. Let's go ahead and refresh. And we're going to see that this is going to run. It's going to check once, checking twice, checking a third time. That was the last one. And there's nothing there. Nothing is happening anymore. We have successfully cleared that interval. So you're occasionally going to see set timeout and set interval. You're not going to see it too often anymore. We used to use this a long time ago to make things look like they were actually doing things. We try not to have any purposeful delays anymore in websites that we make, in modern websites, but occasionally you will see something like set interval, where you need to constantly poll your server for updates. If you're making a chat application, this is where you would start. There's better ways to do it, but this is where you would start. You would set an interval and constantly ping your server for updates. And if there's an update, then you update your document object model. And then you could write some sort of function, and clear interval doesn't need to be in here. Clear interval could be out here as well. You could have a set timeout, and after 8 seconds, clear this interval. You could do that as well. And so that's sort of mixing and matching set interval and set timeout and clear interval. What I'd like you to do is give this a shot, give both of these a shot. If you didn't test out set timeout a couple of lessons ago, give that a shot now. Just take a minute and write one of these. And notice that it does in fact wait 3 seconds because I've set it to wait 3 seconds. And then an interval, do this one as well. I want you to do the full example though. So create your callback function, console log something every time this runs. So this is going to run every 2 seconds. Count plus plus, and then when that count is now equal to 3 or 4 or 5 or 1 or whatever you want to set it to, clear that interval, which means you have to set this as a variable to my interval, or whatever you want to call it, and then use that variable to clear that interval. And then notice how in your console, it's not changing anymore. It's not updating. In the next lesson, we're going to learn about while loops. Now, this is actually a beginner sort of lesson. We purposely avoided it in JavaScript 101 because it's somewhat dangerous, but it's also very, very powerful. While loops will basically run forever until you tell them to stop. And so we've seen for loops before, and you've probably even seen a for each loop before. Now we're going to tackle a new one called a while loop. And this is actually one of the old ones. This is one of the ones that existed along the times of for, but this one is called while. And so the idea here is while something is true, execute this code. And it's going to do this forever. So be careful here because you can crash your browser. You're not likely to crash your computer. Your browser will crash long before your computer crashes if you're using a modern browser. But the idea here is that this will run forever and ever and ever until something is no longer true. So what we can say here is let num is equal to 0, and let's say something needs to be true all the time. So while num is less than 100, go ahead and execute this code. So we'll say console.log num. Now the important thing here is, unlike a for loop, a while loop, you need to explicitly make sure that this becomes false at some point. And so we could say num++, and that's simply going to say execute this. On the first iteration, num becomes 1. Second iteration becomes 2. Third iteration, it becomes 3. All the way up to the 100th iteration, it becomes 100. Then it's going to say 100 is not less than 100, so this is now false. Stop executing it. So let's go ahead and give this a shot. And the important thing here is that we are at some point making sure that this will become false. Because right now, this is true. This is saying while 0 is less than 100, execute this. and then it's going to do the second iteration, third iteration, fourth, fifth, all the way up until it gets to 100. This is no longer going to be true, so stop running it. But we're going to use a variable instead. So let's go ahead and save that and refresh, and we're going to see this console logs 0 to 100 pretty quickly. Just like that. 0 to, I said 100, I meant 99, because 100 is less than 100. That's a false statement, that's incorrect. But we have 100 numbers in here because we started at 0, that's what I was talking about. We started at 0, 99, so 99 plus an extra number is 100. So we have 100 numbers in here. And so this is a really good way of making something happen right away. Now JavaScript is fast. And so if you're trying to ping your server over and over and over again for like a chat update, for instance, this is going to hit your server 100 times nearly instantly. And that's going to bog down your server. So you would rather use a set interval for that rather than a while loop. Now where this gets interesting is you can do something like this, while true, and then at some point you can break out of this loop. And you'll see this a lot in Python, PHP. You'll also see it in Node.js. So while something is true, keep doing something. And so we could ask for someone's name. So we could say, let name is equal to prompt. What is your name? And then we can say if that name is equal to strict, because every piece of user input always comes in as a string. Even if it's a number, it comes in as a string. So we're going to say if that name is a string and also happens to be Caleb, let's go ahead and break out of this loop. Otherwise, let's not break out of this loop. This is going to be false if it's a different name, and say console.log wrong name. Wrong name, try again. And so at this point, we're basically creating a guessing game. And so let's go ahead and refresh this. And it says, what is your name? I could put in Jacob. Nope, not going to work. I could put in Steve. Not going to work. I could put in Caleb, and that's going to work. And it says, wrong name, try again, wrong name, try again. So I guessed Jacob at first, then I tried Steve again. Didn't work. It just kept going. It just kept working until I told it to break out of this loop. So there's two ways to break out of a while loop. Now what I would like you to do is give both of these a shot, because this one is a really good way to create a guessing game, and where you ask for a number, and then if that number is the right number, break out of the loop. Otherwise, ask again. Maybe tell them they're wrong. Maybe tell them to try again. You can create a guessing game with 6 lines of code. Anywho, go ahead, give this a shot. Make sure that you always have this little fella right there, so that eventually this statement up here becomes false. Or if you're just using while true, make sure you definitely have a break statement. You can also use break up here if you wanted to say if number is equal to 50, break, and that will get out of the loop and it will only console log up to the number 50. Regardless, I'd like you to give this a shot. Just make sure, yeah, you have some sort of way of verifying this is false, or you're breaking out of that loop with some sort of conditional. Remember, you're not going to hurt your computer, but you might crash your browser. If you crash your browser, you're going to want to comment your code, open up the file again, so it doesn't keep crashing your browser over and over again. That gets a little frustrating, a little irritating. But you can always comment your code out, reopen the file, rewrite some code, uncomment it, try it out again. In the next lesson, let's go ahead and talk about date formatting. Date formatting is really important in JavaScript, but there's one little caveat, and I want you to keep this in mind, that when you are working with dates, they are local to your computer's time. So keep this in mind when moving through this lesson. So let's go ahead and create a new variable date. So let's do let d for date is equal to new date. And this is getting into objects. We see new here. We'll talk about this more down the road. And let's say it's the year 2025 and it is January 15th. So we have year, month, day. We can get more specific. We can put in hour and seconds and things like that as well, but we're going to keep it simple here. And so we have d is a new date object. And so here you can see that I'm using February 15th. So I forgot about a thing here. So months actually start at 0. So if I wanted to do January, I would do this. There we go. Wednesday, January 15th, year 2025, GMT -7 Mountain Standard Time. That's my time zone. Now keep this in mind, because if you're in Russia or Germany, or even on the east coast of North America, your time zones are going to be different. And so this could say something like Wednesday, January 15th, 2025, GMT +11. And technically that's going to be the same day, but it's going to act different for you than it is for me. So time zones are tricky. Time zones, honestly, time zones kind of suck to work with, but the date object is pretty nice. And so we can say something along the date of d.get full year, and this takes parentheses here. So we're going to see d.get full year is the function name or the method name. And because it's a function or a method, because it's on an object, we'll talk more about this down the road, we use parentheses. So it gets me the year, 2025. What if I wanted to get date? Gives me the 15th day. What if I wanted to get month? This is going to be interesting. It says 0. January is 0, February is 1, March is 2. See, I'm already getting that mixed up. And December is going to be 11. And so what we could do here now is say const months is equal to Jan, Feb. And so I just wrote the months out here in an array. And we know that if I did months 0, we get January. Likewise, if we get months 11, we're going to get December. And again, that's because lists or arrays start at the number 0. So 0, 1, 2, 3, yada, 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 10, 11. So now we can say something interesting like months, d.get month. And we know that this is going to return 0 because we said January. So it's going to go into this month list or this month array. It's going to look for the 0 index. That's the very first one, January. And this is going to say Jan for us, just like that. And so now we have successfully turned a month date or a month number into a month name or a string. And you're going to see something like this all the time when you're working with dates. This is actually super, super common code that you're going to see. What I would like you to do is, again, do let d is equal to new date, put in year, month, day, like what I did, where I did 2025, 015, and then do d dot, and you can see all these different ones in here. Get hours, get milliseconds, get minutes, get month, get seconds, get time zone offset. Interesting, 420 minutes offset. But whenever you type d dot, you're going to see a lot of different things in here. And I want you to go and explore some of these. There's a lot of gets in here. These are called getters. There's some in here called setters, so you can actually set the year as well. So if we wanted to set the year to 2020, we just change the year from 2025 to 2020. So go ahead and tinker around with that, have some fun with it. You're not going to break anything, and just use your console. So all I did was right-click on my page, inspect, open up your console, and just write that out. Go ahead, tinker with it, have some fun with it, explore it, spend maybe 5 minutes playing around with it. When you're done with that, let's head on over to that next lesson. Let's take a look at destructuring arrays and objects. And this is modern JavaScript. You're going to see this a lot. So let's say we have some sort of array, and let's call it months. We could say const months is equal to January, February, and let's not go in order. Let's also say December for no particular reason whatsoever. Now let's say we just wanted to get the first two. What we could say here is const, and this is destructuring. So we're going to set two variables to be the first two in here. So we could say const Jan Feb is equal to months. And all this is going to do is pull out that first one and that second one. And then we can console.log Jan and Feb at the same time. Let's go ahead, go to our browser. I just saved that page and refresh. And we're going to see January, February. And it didn't pull out December. And months still exists. So we could do console.log and just type in months. And we can see January, February, December still exist in this array, but we pulled out January and February. That is how we destructure an array. So I'm going to leave this in here with the comment destructuring an array. I have no idea if I spelled that right. Nor do I care. Let's talk about destructuring an object. Now this one is a little more picky. So let's say we have a const of person 3. And this is an object. So we've got name, Caleb, and Instagram at coding.for.everybody. And then something else is equal to something else. Doesn't really matter here. And so this is just a standard JavaScript object. We learned about these in JavaScript 101. Now, let's say I wanted to get the name and Instagram. Well, I could do const name is equal to person 3, name, and I could do the same thing here, Instagram. And basically I've just written 2 lines of code that do the exact same thing. With modern JavaScript, we can destructure this, and we can make this faster. So instead of writing these 2 lines, what we can write is a destructure. So we could say const, and because it's an object, we're going to use curly braces. Just like in the array here, we used curly braces when we destructured our array. In an object, we're going to destructure using an object. And that's just how JavaScript knows that it's going to be destructuring an object. And now we want this to be name, and this matches the key up here. And Instagram is equal to person 3. And if I get rid of those other ones in here, name is now going to be Caleb, and Instagram is now going to be person 3. And so I can save that, go back to my page, refresh, and I didn't console log, but I can now type name, get Caleb, and I can type Instagram. I can also type person 3, which is the entire object, and you'll see that Instagram, name, and something else, it's just in alphabetical order now, it's all in there. So nothing was actually pulled out of it permanently. All we did was say name is equal to this name here, or this name is equal to this name, or Instagram is equal to Instagram. Or if we didn't want to do it in order, we could do something else is equal to something else as long as it matches. Let's go ahead and refresh our page, and let's type something else. We'll see that it says the value. And so these values here, these new variable names, just match the object property name. So something else, or Instagram, or name. And so in this case, we didn't pull out Instagram, we just pulled out name and something else. I'll undo that as a better example here. There we go. And that's how we pull out just 1 or 2 things and assign them to their own variables. Now what's nice about that is you don't have to access things like person 3 name. You don't have to write this over and over and over again. You can just shortcut that to name. And because if you're using a const, you can scope that to like an if statement. So let's say you have some sort of if statement in here. If a thing is true, move that in there. And now name and Instagram are going to be scoped to this set of curly braces. And you don't have to worry about like reassigning name down the road or what person something else is doing. You can simply work with name and Instagram within these curly braces. That's destructuring. What I would like to give you as homework is I want you to destructure an array. Don't forget, an array has these hard brackets. So when you destructure, you use hard brackets. Then I want you to destructure an object. And an object has the curly braces. So when you destructure, you use curly braces. Go ahead, give that a shot. Make sure that you are actually pulling it out correctly. You can type name into your console and you can see your name. Again, this is modern JavaScript and you're going to see this everywhere. This is very, very popular these days. So it's good that you know this. We can delete object properties, but we cannot delete entire variables in JavaScript. So we use the keyword delete, and you can actually see that it gets highlighted here in pink for me. Delete. And then we put some variable name. Now in other programming languages, you can delete entire variables. In JavaScript, you can only delete object properties. So this is not going to work for us, but we could create some sort of property, const person4. Let's go ahead and give that an assignment operator. Name is equal to Caleb, and the age is going to be 31. And so I can console.log person4 age. And when I go to my page and refresh, it says 31. Now let's say for some reason I wanted to get rid of that. I didn't want my age to be accessible in here. What I can do is keyword delete person4 and then just give it the key age. And this will no longer say 31 when I refresh the page. It says undefined. It doesn't exist. So we've successfully deleted this. Now let's go ahead and see what happens when we try to delete this entire object. And in fact, let's go ahead and console.log person4. We deleted it, but it still shows up. So it doesn't actually work. Now, the nice thing that we can do here is use strict. And we talked about this a while ago. Use strict. And this is going to give us an error. Let's go ahead and refresh. And it says, uncaught syntax error, delete of an unqualified identifier in strict mode. Means you cannot delete this entire variable. We can delete a property though. Let's go ahead and delete age. And we can see that we deleted age, and now it's just an object with name and Caleb in it. We successfully got rid of this. Now, this is another nice use of use strict. If you use strict and you try to delete variables, it's going to tell you you can't, because you simply just can't in JavaScript. It doesn't work that way. But you can delete an object property. And so by using strict, you're making sure that you are in fact writing stricter code, and you're going to run into an error whenever you see some illegal code, or whenever you write some code that doesn't work. So again, this is a good use case for using use strict. Now what I would like you to do is go ahead and create a new object. Give it a couple of key value pairs in there, and delete one of those properties. Then console log that entire object, and when you do that, you should see that whatever you deleted is no longer in there. Then, as step 2, enable use strict and try to delete the entire variable. Just try to get rid of it entirely and see that error. Once you see that error, you know that use strict is enabled and things are working the way we expect them to. Alrighty, welcome back. In this lesson, we're going to talk about some math. Now, math in JavaScript comes in a module called math. And what I'm saying here is math. And if I type math dot, you're going to see all these different things that we can do. And we're not going to cover all of these because we're going to be here for a lifetime if we cover all of them, but let's cover some of the popular ones. Like round. If we wanted to round let's do 4.6. This is going to round up to 5. We could also round 4.4, and this is going to round down to 4. And this is how we quickly round numbers. So instead of doing a bunch of math, we can just tell the math module in JavaScript to literally take whatever number we're giving it and round it. We can also do power. So math dot pow. So this is an exponent. We can see this as a function, takes x and y. So let's do 8 to the power of 2, and we're going to see that this is 64. And then, just as a fun little example, in sort of more modern JavaScript, not like super new JavaScript, but more modern JavaScript, we can also do 8 to the power of 2. So 8 times is an exponent operator. You're going to see 64 as well. And so math.pow is the old way of doing it. 8 times, or to the exponent of, is the new way. They do the exact same thing. We can also get the square root. So we can do like math.sqrt, and let's get the square root of 9. Gives us 3. Let's do the square root of 8, let's do 8. 2.828427, yada, yada, yada. Gives us a square root. And so basically we've got a calculator to do anything we want at this point. We just don't have the buttons to press. We just have to type it in though. Another really useful one is max and min, or a couple of them. So math.max, and we could say 1, 4, 43, and 10. And this is going to give us 43. So it's going to look through all of these and give us 43. So it's going to say, is 1 the highest? Is 4 the highest? Is 43 the highest? Is 10 the highest? It says, nope, 43 is the highest, return 43. Next up, we have math.min. And we can do the same thing. It just takes any number of values. And we can see that here. So ... that's a rest values. That means it'll take any number of parameters. So let's do -30, -29, -31. And just for funsies, let's do a positive number. And we're going to see that this returns -31 because that's the smallest number that we gave it. Now let's go over 2 more really popular ones we're going to see in here. math.floor. This is going to take any number you give it. So let's do like 23.1. In fact, actually, let's do 23.9. So if we were to round this, this would be the number 24. But what this is saying is just take this number. So always round it down to its closest whole number. So this is going to be 23. And that just floors the number, brings it to its lowest value, whole number value. We can do math.ceil. That's short for ceiling. And we could do the same thing. We could do like 23.1. Now, if we used floor, this would be 23. If we rounded, this would be 23. But this is saying, take this number, and if it's not exactly 23, if it has any decimal at all, round it up to the next number. We're going to see that it's 24. And these are really popular when we were working with things like random number generators, which we're going to be using in our final project, so this is really important to pay attention to. Now, if you're ever wondering, you can do math dot, and then you can do like ABS, all sorts of things. Cosine, sine, log, max, min, pow, random, we'll talk about random in a little bit, tan, all sorts of things. You can do lots of things in here with the math object. Or if you don't want to use your console, you can always go over to developer.mozilla.org. And in here, you can just see all these different methods, and they'll give you more information on it. So if you're ever wondering what ABS does, if you pick up someone else's code and you're like, what does math.abs do? You could read through this. You can run, you can reset the code, you can read about it in here. You can even see which browsers are fully accepting math.abs, for example, or math.pow. Let's see if there's any browsers that don't support POW. I don't see why they wouldn't. Looks like everything supports. Oh, wow, it even has Node.js in it. That's pretty cool. So if you're ever wondering about specs, I would always recommend going to developer.mozilla.org. And these are the Mozilla Developer Network web docs. It's called MDN for short, Mozilla Developer Network. Currently, I'm actually working with Mozilla, and they are a great group of people to work with. And their documentation is fantastic. Hands down, the best documentation you will ever see. So go ahead and give all of these a shot. There's math.min, math.floor, ceil, max. What else do we do in here? Square root, pow, round, all sorts of stuff. Go ahead and give that a shot. Just have some fun with it. You don't really need to know too much about it. Again, the big ones to take away here is going to be math.floor and math.ceil. These are going to be the two big ones. Okay, let's take a look at math random. And so this is one we didn't touch on in the last lesson, and I purposely left it out. Let's look at random. And so when we want to create a random number, we do math.random, and this is going to give us a number between 0 and 1. And it will always give us a different number. And we can see that no matter how many times we use this, it gives us a different number. And that's just randomly giving us a number between 0 and 1. So if we wanted to, let's clear that. If we wanted to, we could create a random number between 0 and 100 pretty easily. We could do math.random multiply 100. And because we know if that number is going to be between 0 and 1, we can multiply by 100 and get a number between 1 and 100. And here we go. We got 38.8. Instead of a decimal, we're using basically full numbers with decimals. Now, if I wanted to, I could also floor this. And this is why in the last lesson I said this is really important. Because I could say math.floor, and then in here we could say math.random times 100. And so that's going to execute this in here. So it's going to give us a number between 0 and 100. And it's going to have a bunch of decimals on it. And this is just going to round that number down to the closest whole number. And that gave us not a number because random is a function. It's a method. It needs the parentheses there. 78, 21, 71, 93, 37, 4, 13. You get the idea here. It's always going to be completely random. Now let's say you're making a random number generator and it has to be between 0 and 83. You could do math.random times 83. And that's always going to give you a number between 1 and 83. And that's actually strange that that showed up there as the number 1. It seems improbable, doesn't it? But it'll always give you between 1 and 83. And then you could, again, math.floor or math.ceil this and get rid of those decimals. So this is going to round up to the closest whole number. So 68, 6, 41, 70. Now this is going to be really important for your final project, so make sure you actually do this. And I would like you to open up your console and just tinker around with math.ceil, math.floor, and math.random. All right, at this point in time, I have given you all the tools that you need to create a random number guessing game. And this is going to be pretty annoying, actually, and that's the whole point, is to be consistently irritating until you guess the right number. Now, what we could do is we could say random number is equal to 13. And let's set that as a constant, and then we could say if the number is 13, whatever the person puts in, is if the number is 13, then they win. But that's hard-coded, and that means you can right-click, view page source, and you can see whatever that number is going to be. Instead, what I want you to do is use a while loop while something is true. I also want you to use some sort of prompt, ask for the number. And then you're going to need to compare if whatever that number is equal to a random number, that random number, which also means on every while loop, you're going to need to create a random number. So you're going to have some sort of random number is equal to a random number between, let's say, 1 and 10. And if they guess the right number, say that they're correct and break out of the loop, otherwise ask again. I want you to give this a shot. This is going to be pretty tricky, I think, at this point, but it's also really good practice. So go ahead, give that a shot. And when you're done, if you want to see my solution, you can just resume the video. So I'm going to fade out and fade back in, and you can see my solution to this. All right, I'm going to create a random number guessing game. So the first thing I want to do is, while something is true, we want to ask what that number is going to be from the user. So we could say, let number is equal to prompt, guess the number. Now I'm also going to set number is equal to an actual number. I'm going to cast this as a number. And we learned about casting in JavaScript 101. If you didn't learn about casting yet, or if you haven't learned about casting yet, all this is doing is saying this is going to be a string. So if someone types in the number 13, it comes in as the number 13 in a string. This is simply casting it to be an actual number. So now we can use a strict comparison. So now we can say if number is equal to random number, which we don't have yet, alert, you win. And let's break out of this loop so it doesn't ask again. Now we don't have random number. Let's go ahead and create random number. Now I said random number is going to be between 1 and 10. So we can say const random number is equal to math.ceil math.random times 10. Now we know math.random is going to give us a number between 0 and 1. And if we want it to be between 1 and 10, we just multiply by 10. Or 1 and 100, we multiply by 100. And then we're going to take whatever that number is. So let's say it's like 4.12345. That's going to seal it. It's going to hit the ceiling. So that 4.12345 is going to turn into a 5. So now we have a random number in there. Let's go ahead and leave some space for our code. And let's scroll down and say else. I also want to do a strict comparison here. So it's going to check to make sure it's a number. Now, if someone types in something that can't be converted to a number, we're going to see some sort of error, or it's going to be turned into NaN, not a number. And what I was saying there was NaN, stands for not a number. Okay, so if that number was right, cool, it says you win, break out of this loop. Otherwise, it's going to do some other piece of code, and it's going to execute this again. It's going to execute this forever. So what we can say now is console.log, you guessed, and then the number, but the right number was random number. We could also turn this into a template literal if you wanted to, or we can just use a regular console log concatenation like this. I'm just going to stick with the old school way of doing this. Let's go ahead and load this up in our browser. So I'm going to refresh, guess the number. I'm going to guess 8. Nope. 2. Oh, it was the number 2. Yay, I didn't have to guess over and over and over again. Okay, now let's look at our console. It says you guessed 8, but the right number was 5 the first time. The second time I guessed 2, and it was actually the right number, so it broke out of that loop for me. It will just keep asking over and over and over again until you get it right. Now, I suggest using numbers like 1 to 10 or 1 to 5. This way you can actually guess the right number. If you guess between 1 and 1,000, you'll probably never guess the right number. And this just allows it to be winnable. Now, the nice thing here is when I right click on the page and go to view page source, you're going to see const random number is equal to math.ceil math.random times 10. It's not hard coded. So it didn't say random number is equal to 2. It's going to change every single time this loop runs. Every single iteration, that number changes, so it gets harder and harder. That is a random guessing game, or random number guessing game. Now, if you wanted to, you could make this a lot nicer. I just use plain old JavaScript, but you could use your entire page if you wanted to, and you could ask someone to type in into an input field or a form and hit submit, and they could guess over and over and over again. That way, you can do all sorts of things with your document object model and make it look nice. We just did the bare bones, real ugly way just to really drive the point home, and we don't have to focus on too much of how things look at this point in time. Plus, you can make it look however you want it to look. Up next, we're going to learn about try and catch. And what I'm saying here is go ahead and get rid of that. Try and catch. So we have seen uncaught reference errors. We've seen uncaught syntax errors. We're going to try and catch those gracefully. Trying and catching is how we gracefully handle errors. And frankly, this is not used nearly enough by developers that write JavaScript. Meanwhile, it's incredibly common in things like Python. It's becoming more common in PHP as well. But not enough people use this in JavaScript. So if you learn how to use try and catch in JavaScript, you are really leveling up your skills here. You are starting to write really solid, fluid code that can gracefully handle errors. And the idea is when you run into an error, don't make everything else fail just because you wrote a line of code and it did an unexpected thing. You want to gracefully catch that error and work with it. So let's take a look at the syntax here. It's try, and then we've got curly braces, and then catch, and then whatever that error is called, and we can console.warn the error. And we need to make sure that something doesn't work. So let's use a function that doesn't work. Function that doesn't exist. And we're going to try to call this. And now this is not going to do anything except throw some sort of error. And then we're going to take that error and we're going to warn the console. So if I refresh this page, it does warn, so it's in yellow. Reference error. Function that does not exist is not defined. Now, let's do this. Let's do console.log show me. And all we want this to do is actually show up. Cool. We've done this a million times. We know how console.log works. What happens if we didn't have this in a try catch? If we get rid of that try catch in here and we just run function that does not exist, my console log doesn't show up. Now, what if it's running something important? What if it's making an API request to see if a user is logged in? Well, because this function doesn't exist, maybe there's a typo. I don't know. But for whatever reason, it gave us some sort of error, and this line is no longer executing. JavaScript gets here and says, oh, sorry, don't know what to do, and completely falls over. And so to make sure that your code doesn't fall over, we wrap it in a try catch block. Now, when it gives you that error, that's called throwing an error. And it says uncaught reference error. It is throwing a reference error at us, meaning that reference to function that does not exist is not defined. It's the whole error. We can also throw our own errors as well with the keyword throw. So throw Caleb's custom error. Let's go ahead and refresh our page. Show me still shows up, and Caleb's custom error shows up. And now that's in here. We can even make sure this works by saying error logging. And so it says error logging, Caleb's custom error. That's what I threw. I threw Caleb's custom error. It caught it in here. Now what happens if I try to console.log a thing in here? Now what JavaScript is going to do is it's going to try to execute from top to bottom. But just like in a function, when you use the return keyword, nothing below it is executed. In a try catch block, it's going to try. It's going to see that there's some sort of error being thrown in here for whatever reason. Maybe someone put in the wrong username and you want to throw an error, wrong username. Well, it's going to hit this throw keyword and immediately break out of this block. So this line is not going to be executed. Then it's going to run that catch. So Caleb's custom error becomes the actual error. That's the variable name. And then we can work with that error if we wanted to. So let's go ahead and refresh this. And it doesn't say a thing in here. It says Caleb's custom error. So what's nice about this is it tried to execute some code in here, ran into an error. That's fine. We caught that error. We gracefully handled that error, and our code keeps running. That is the most important thing. And I cannot stress this enough because I run into this dozens of times a day where I go to a website like even Facebook and I try to do something and JavaScript runs into some sort of error. And because it runs into an error, the rest of the site doesn't work for me. And as a user, that is extremely frustrating. Now, as a programmer, there's a way around that. Try catch. You can try some sort of custom logic. If it doesn't work, you can throw an error and make it work. Now, there's another block in here that we can call called finally. So we have try, catch, and finally. And what this does is whether this code executes or this code executes, do something in here. Do something in here. Now, you're not going to see finally too often because regardless of the situation, you could just write more code in here. And so sometimes you'll see a try catch finally, but most of the time you'll just see try catch because regardless of what happens, your error is caught. This is now going to execute the code below it. And so what we could say here is, let's do const num is equal to 10 and num is equal to num plus 20. So we know that's going to be 30. It's going to console log an error if there is some sort of error in there. And then we could do finally console.log. The final number is num. Now we know that this is going to throw us some sort of error. We can't reassign a const. It just doesn't work. That's the whole reason why we have const, is it should be constantly one value. So let's go ahead and save this and see that this is going to throw some sort of error. We're going to catch that error and we're going to say the final number is whatever num is. So it could be whatever num caught here, it could be whatever num caught here. We could even say num is equal to num plus 15. Now that's only going to work if this is a let, so let's not do that because I want this to break. But we could set, for example, a variable in here and use it in finally. Just remember that if you are using const or let in here, that it is block scoped to your closest set of curly braces. So if you used const name, it's going to be blocked, or it's going to be scoped to this block here. So just keep that in mind. Let's go ahead and refresh this. Error logging type error, assignment of constant variable, and the final number is 10. And so basically it said constant number is 10. Try to add 20 to that number. If there is an error for whatever reason, log that error. And then finally, doesn't matter which block was run, either the try or catch, finally execute this console log. And that tells us the final number is num. It's 10 because it couldn't be reassigned. It just doesn't work that way. Now what I would like you to do is give this a shot. Write a try catch block and write some sort of code that's going to be an error. You could even do something like num.to uppercase. And because this method doesn't exist on a number, this is a number, not a string, it's a number, you can't turn numbers into uppercase. So what's going to happen here? Well, let's go over here and see. Num.to uppercase is not a function. Doesn't exist. Go ahead and give that a shot. But make sure you catch that error gracefully, and then make sure your code after it runs. So code in here should still execute properly. So yes, please try this out. This is really a good way to level up your JavaScript skills. And one thing to note is typically we do not nest try excepts or try catch blocks inside of try catch blocks. We just don't do that. You can do it, but it gets really messy. So instead we write one here, and then we would write another one down here if we wanted to. Just try not to nest them inside of each other because that gets really messy and hard to keep track of. But yeah, that's your homework. Write a try, catch, finally block. When you're ready, let's head on over to that next lesson. Let's talk about the this keyword. This is a keyword. I'm using the word this, and you can see it actually highlights red for me in my editor. This is a keyword that refers to the entire body of an object. It refers to the object that it belongs to. So let's go ahead and create a new object. Let's do const person5 is equal to, and let's say the name is going to be Caleb, and Caleb, comma, and I'm going to use an object literal here, which is the exact same thing as saying speak is equal to function speak, something like that, or rather speak is equal to function and then something like that. Instead, we're shortcutting it and we're just saying speak. Yeah, we can get rid of that. That is an object literal. And we want this to be console.log meow, because apparently I'm going to say meow today. And so I can execute this with person5.speak. And when I refresh my page, it says meow. And that's really nice. This is how we access an object. Now, this is called a method on this object. Because it's part of an object, like a function or a class or an object, this is called a method. Now, what if I wanted to say, my name is Caleb? Well, when I go back here and refresh, it says my name is Caleb, as expected. We know that was going to happen. But what if that name wanted to be dynamic? And what if I wanted this to be a variable? Well, I could try name is equal to name, and then Let's use a template literal here so we can put variables inside of this string. And this is going to take whatever name. So my name is Zephyr. And it says my name is Zephyr. Now that's great and all, but that sort of defeats the purpose of putting this particular method inside of this object. This could just be a regular function. So let's get rid of name. And instead, let's say we wanted to access this name up here. Well, how do we access that name? Well, we could do person5 name. And as an example, let's go ahead and I'm going to show you that this works. Person5 name. And we can get rid of that because speak is no longer taking any parameters. And it says, my name is Caleb. So that works. That's nice. There's a better way of doing this though. We could do this.name. And when we use this, it's referring to this entire object. So we don't need to have just name. We could put age, favorite food. We can have an object inside of an object inside of an object. We could have a function in there. We could do all sorts of things. But this is referring to this entire object, not any other object. It's just referring to this particular object. And so when I change this name to like Henry, and it's a name, so capital H, it says my name is Henry. Now that's one example. We can also do this with functions. So let's go ahead and create a function. Counter. That's what we're going to call it, counter. And so functions also come with the this keyword. And so we can say, if this dot total is equal to undefined, because it doesn't exist, there's no counter dot total yet, we could say this dot total is equal to 1. Otherwise, if it is defined, and it will be defined after we run this at least once, we can say this dot total plus plus console.log running counter total is, and then we can say this dot total. Now, out of the box, this isn't going to do anything. What we want to do is execute this function. So this is going to execute it and say this dot total is 1. Running counter, this dot total is 1. What happens if we run this over and over and over and over again? I don't know how many times I copied and pasted that. It's going to let me know though. And this tracks how many times this function has been run. Now you don't need to particularly count or track how many times this function was run. You could do anything. You could say, if this dot name is equal to undefined, set a default name. Now what's not going to work, and what we're going to talk about in the next lesson is, I'm just going to copy a bunch of these, is an arrow function. And so I could do const counter is equal to an arrow function, and the this keyword, it exists, but not in the same manner. So when I go back here, you're going to see that this actually works. It says 1, 2, 3, 4, 5, 6. That's how many times it copied it, but it's not referring to this particular object or this function anymore. And we'll talk more about that in the next lesson or the next episode where we talk about arrow functions. An arrow function lets us write shorter code, but they can also seem a lot more complex. They're actually quite easy though, but if you're just looking at code and you've never really seen an arrow function, they seem super scary. They don't have to be though. And so we could write const hello is equal to a function, return hello Caleb, and then we could execute hello. So const greeting is equal to hello console.log greeting. And what we're going to see here, hello Caleb. That's a standard function. Actually, this is an anonymous function. We've assigned it to const hello. We can also do function hello, execute this function and store it in a different variable. Two ways of doing the exact same thing. When I refresh, it says the exact same thing. And so this is a typical function. So another way of writing this could be const hello is equal to brackets, arrow, and that. And so essentially what we've done here is function hello is equal to something like that. This is the old way of doing it. The new way of doing it is const hello, brackets, arrow, console.log hello, hello. And we could type hello and execute it, and it's going to say, and it's going to say hello. Okay, that's one way of writing it. There's another way of writing it. We can actually make this a lot shorter. And in fact, we could simply do const hello is equal to opening and closing curly brace, not curly braces, but parentheses, an arrow. And then in a normal function, we use the return keyword. We use the return of the king keyword. And we don't need to do that. If this is going to be on a single line, we can just say this is going to execute some sort of function. And so this could say return hello from one line function. Let's go ahead and execute hello. And that's not going to do anything because I needed to console log it, but let's shortcut that and let's just run hello. And it returns. And so all this is doing some sort of logic. In this case, we're just returning a string and storing it in const hello. Then we can run it as if it were a function. Now let's look at some of the syntax here because I went kind of fast. So let's do const my new greeting is equal to, let's take a parameter, name, arrow, and then I can do console.log, and we can use a template literal in here, and we can say welcome name. And remember, template literals need those backticks, otherwise your variables aren't going to work. And so now I can use my new greeting, codingforeverybody.com. Welcome, codingforeverybody.com. Or welcome, Caleb. And all this is doing is saying, hey, if there were no parameters, you don't need to add any parameters in there whatsoever. But if you do have a parameter, throw it inside of those, not curly braces, but your parentheses. If you have a second parameter, it's just comma, second parameter. And so on and so on and so on. And you can work with those in here. Now, in our example here, we really only have one line of code. What do we want it to do? Let's go ahead and get rid of these curly braces because it's only executing that one line of code. Make that just a touch smaller here. And so my new greeting is equal to, it's going to take some sort of name, and it's not going to return anything per se, but it is in fact going to console log welcome my name. And so this is going to work the exact same way. So if I go here, clear that and refresh, it says welcome Caleb. Every time I refresh, it says welcome Caleb. And just to really make sure that this is working and it's not cached, Caleb 123 123 123 123 321. And so that's working as expected. So as a quick comparison, you're going to see function, my function name, maybe it takes a parameter, does a thing in here. You can also do const anonymous function is equal to a function. Do a thing in here. This can also take a name. And this is pretty common. You'll see this a lot in modern JavaScript as well. We also have arrow functions. So you could say const arrow func1 is equal to, takes no parameters, do a thing. So if you've got multiple lines, you can do multiple lines in here. So multiple lines. This will also be able to take a parameter or more. These can all take more than one parameter. Or if it's only doing one line of code, you can do const arrow func2 is equal to, if you have no parameters, no parameters. If you have a parameter, you could throw it between those parentheses, arrow, and then whatever you're going to return or whatever you want to do in one line. So these are the two older ways of doing it, and there's a reason we do it this way still. And these are the two newer ways. And so the idea here is that when you use the word function, the this keyword exists. So like we saw in the last lesson where we did this.name, that exists. Now it also exists inside of an arrow function. The difference is when you use the keyword this, and I'm saying THIS, is this in this circumstance and this circumstance here, these two, it's referring to this as an entire object. So it thinks that's an object, it thinks that's an object. The this keyword, it still exists here, but it's not referring to this object. It's referring to the outer object. So maybe it's wrapped in a function. Maybe it's wrapped in an object. Maybe it isn't wrapped in anything and it's referring to the entire window itself, the whole global scope of your JavaScript ecosystem. And so one is localized, so this is smaller, and this one is using everything globally, everything it can get its hands on. That is the main difference. Now, if you're not using the this keyword inside of your function, I would highly recommend just using an arrow function. It's more performant, your JavaScript doesn't need to think about as much, you can write bigger applications that aren't going to crash or slow down your browser better. It's also more modern, and employers are going to like to see that you can actually write this kind of code. Now, what I want you to do, and should take a few minutes, should probably take 10, 15 minutes, I want you to write the 4 different types of functions here. A normal function, an anonymous function, an arrow function with multiple lines, and an arrow function with just one line of code. And then I want you to execute each of them. Make sure that they work. This is really, really important. This is vital to being able to get a job as a modern JavaScript developer. Go ahead and give that a shot. Don't forget, if you have questions about this, come join the Learning to Code Facebook group and ask questions in there. I am happy to help. We have tons of people who are willing to help, and tons, thousands of people, over 60,000 people who know how to code. And I'm sure there are thousands of them that know JavaScript that might be able to answer your question faster than I could possibly answer your question. So don't forget, there is a free support group out there. Otherwise, good luck, and I'll see you in the next video when you're nice and ready. Classes are a lot like standard objects, but they're written in a more friendly way. In fact, you can think of this as 2 different ways to basically write the same set of code, and then classes can get significantly more advanced and more developer friendly, actually. So a class is really just another way of writing another object. And if that's the case, why have 2 ways of writing objects? If we have one way that works, why use a new way? And in modern JavaScript, you're going to see people using classes all the time. This is a very common thing these days. So while they are very similar, they being classes, have better features, like being able to write one class and merge it into another class with this thing called subclassing or extending. You can also write the same method twice and have it execute on both of them quite easily without overwriting them. And classes just look easier to read. Classes are also cleaner to write. You'll see a lot of these in production level code bases. Plus they look a lot like PHP and Python classes, which means now at this point you're learning object-oriented programming, which means once you learn this lesson, you are basically getting experience learning Python, PHP, Java, C, all these other OOP languages you're getting hands-on experience with by learning it in JavaScript. So let's go ahead and take a look at this. So a class starts with a keyword class, and then it has some sort of name. Now, often you'll see a class actually doesn't follow camel casing. It follows just normal casing. So it could be my class name, follows standard uppercase naming conventions like that. Not all the time, but you will see it a lot like this. And so you say my class name is equal to, Well, it's not actually equal to anything because we're not assigning anything. We're saying my class name, curly braces, and then we can put object literals in here. So we could say something like speak console.log. Woof woof. And so this is the bare bones of a class. Now to instantiate a class, which is a fancy word for saying how to activate your class, you could say const thing, whatever you want to name it, is equal to new my class name. And we saw this in the date lesson where we did new date and then we put the year, month, and day. And at this point we can say thing.speak. So at this point, this code right here looks a lot like a standard object. So let's go ahead and save this and refresh our page, and it says woof woof. And so what it's doing here is saying all this code, jam it into this particular variable, this const called thing. And because it has a method in here called speak, we can do thing.speak. Now where this gets a little more powerful is we can do something like set name, and then it's going to take some sort of name, and we can say this.name is equal to the name. Now this might seem a little weird, a little convoluted even, but what we're going to do here is use set name, set the name to whatever it is, and because we're using this, that stands for this entire object, that's what it represents, we can now say, in this particular method, or this function, speak, we can access it with this.name. And we can say woof woof, says the dog named this.name. And this needs to be a template literal, otherwise we cannot use that. So now we can say thing.setName doggo. And what that's going to do is set the name doggo. And so if we say create a new thing class, a new thing object, set that name, this.name is going to be whatever the name is in this parameter, so it's going to be doggo. And then we say thing.speak. We can now access this.name from setName. And there's actually an easier way to do this. We'll talk about this in the next lesson, but this is a good example of using the this keyword inside of a class. So let's go ahead and refresh, and it says woof woof, says the dog named doggo. And so that's working perfectly. Now what happens if we don't set that name? Currently this.name does not exist. Let's go ahead and refresh our page. It says woof woof, says the dog name undefined. Now if we wanted to, we could get into defaults. We could say something like if this.name is equal to undefined, this.name is equal to unnamed puppers. Let's save that and refresh. And it says woof woof, says the dog named unnamed puppers. But if we go back here and we set thing.setName doggo McDogface, says woof woof, says the dog named doggo McDogface. And so what it's doing here is it's setting that name. It says this.name. Now if that name wasn't set, it's saying if this name does not exist in this particular object, in this class, set it. Otherwise, it's going to be set because we use set name, it does exist. Then use that one. So this is a nice little fallback. You can always use something like this. Now there is a better way of doing this. We're going to learn it in the next lesson. What I would like you to do is basically this. I want you to write a brand new class, write it out by hand. Remember, it starts with the keyword class, then it takes some sort of class name, then curly braces. And then we can put a function in here. Or because it's in a class, we technically call it a method. It is an object literal, so it's going to have the function name of setName, but also the property name of setName. It can take a parameter just like a regular function can, and we use this.name is equal to name so that we can access this somewhere else in a different function without explicitly having to pass it in to this particular function every single time. We can shortcut it. So this is now accessible through this entire object. Name is accessible in this entire object. Next, you're going to need to do const whatever your variable is going to be called, new class name, and then you can use your variable name, .setName, and .speak. Go ahead and give that a shot. when you are nice and ready, when you have a little bit of experience with that, let's head on over to the next lesson where we set automatic defaults for our classes. In the last lesson, we used setName, but we can actually do this by default with a class method called a constructor. And this is a big feature and a big win for JavaScript classes. And we just don't get this with standard objects. And this is where classes start to outpace objects. So let's say we have a class and it's called person. And in the last lesson we did setName, name, this.name is equal to name, right? But then we had to do const p is equal to new person, and then we had to do p dot set name Caleb. And that just, it gets easier. So like, why do it the hard way when we can do it the easy way? So let's go ahead and get rid of this and that, and that. And we have this magic method called constructor. And this can take any sort of parameter. So we could say the constructor takes a name, and then we say this.name is equal to name. And then we can have a normal function in here called greeting. This is an object literal, and we can simply say console.log hello from, and this is a template literal, so we use backticks, this.name. And what constructor does here is we can say const Caleb is equal to new person, and that name is going to be Caleb. And that's automatically going to set this name. So before we had to do .set name and we had to run a bunch of stuff, we don't have to do that anymore. We can just pass it in directly into our class. And now we can do Caleb.greeting, and this is already going to be set. This .name is equal to Caleb. So it's like putting Caleb in here, which then sets it here, which then sets it here. And this seems really absurd. I know that. When you're learning classes, this seems really bizarre, but it's powerful because you can write any number of functions down the road and you don't have to put name in here. You don't have to put name in every single one. You can just use this.name anywhere you want. So it shortcuts it. Let's save that. And let's refresh our page. And it says, hello from Caleb. What if I change that? Hello from Gully. Hello from Gully. Now, if we ever wanted to, and this is a little bit beyond the scope of the constructor lesson, but we could also say setName, and we could overwrite it. This.name is equal to whatever the name is. So let's, by default, set the name to be Gully, and then we could say Caleb.setName. I'm going to rename myself to Caleb, and do Caleb.greeting once more. And this is what my code looks like. I'll just scoot that up into the middle of the screen. And so when I refresh, it now says hello from Gully. I changed my name to Caleb, and when I reran Caleb.greeting, it said hello from Caleb. Now, what I would like you to do as your project or your little bit of homework for this lesson is create a class with a constructor method in it. It should take a name, or it could take multiple parameters. If you want it to take unlimited parameters, you can totally do that too. Set this dot whatever the variable name is, and you're going to see that when I select this, it's highlighted in all three methods here. But if you just set the name, make sure you also set it when you type new person, and then that first parameter is going to be name. If you have a second parameter, you would just give it a second param. And you'd need to do something with this, because this is not going to be accessible in any of these other methods. You're going to need to do this dot second param is equal to second param, and that just makes this accessible using the this keyword in everywhere else. So I'm just going to undo that because I want to keep this nice and simple for you. And I want you to give this a shot. So set the name here and then write another method, another function that accesses it from the constructor. This is really good practice. You're going to see this kind of stuff in production style JavaScript all the time in professional JavaScript, so make sure you are familiar with this. You don't have to be a pro at it at this point, but you need to be somewhat familiar with how this works. So get some hands-on experience with it right away. When you're done that, I'll see you in the next lesson. All right, welcome back. I hope you had some fun with classes. I hope that was actually a little bit hard. just so that your brain remembers it better. They're powerful, powerful things. They are better than objects. They can do so much more, and there is so much more, but we're not going to learn all about it in JavaScript 201 because it gets pretty advanced. But in this lesson, we're going to talk about JSON. And JSON, J-S-O-N, stands for JavaScript Object Notation. And it's basically just a thing some guy made up at some point in time, a long time ago, to make sure that one particular language can talk to another particular coding language. So JSON is a lightweight data interchange format. And that means I can write a particular type of JSON in JavaScript or in Python or in PHP, and it's going to be readable. And so even if my Node.js server can't talk to my Python server, I can send out JSON data that my Python server can then ingest, or I can take in and understand what's going on. So it's a globally recognized way to write code or to share data. So JSON is language independent. It doesn't really matter if it's JavaScript or Python or PHP or C or Java or Ruby or anything like that. And the idea behind JSON is it's supposed to be self-describing and easy to understand. Now, it's easiest to learn JSON by simply looking at it. So let's create a new file. Let's do a JavaScript file. And we're going to have some sort of object. So const object. And in here we could have name, Caleb. Fave foods is an array of pizza, tacos, I don't know, salmon. And we can have age, 31. And we can make this object even more complex. We could say children. And this could be an array of objects in here. Name is equal to Zephyr. He's actually a cat. And his age is going to be 4. And another one in here. This name is going to be Gully. He's also a cat. I'm not entirely sure what his age is. I'm going to guess 4 or 5. And so we have this object here. And this is written in JavaScript. Now, the nice thing about learning JavaScript first, or at this point in time when you're getting into JSON, is that JSON is literally this. Let's go ahead and delete that. This is JSON. And so this is JSON. This is all it is. It looks like a JavaScript object. And as we know, objects can hold a property or a key and a value, or it can have a property and that value could be an array, or a number, or a Boolean, or a list of more objects. This is all JavaScript is. And so whenever you're working with an API down the road, and for our main project here, we are going to be working with an API that uses JSON. It's going to look a lot like this. And the idea is that we have some sort of data in here that we can access on another computer. So if they want to share data with us, that's basically what an API is when another computer decides that they're going to share data with us. We can then use that data in a globally recognized and unified way. So we don't have to worry about XML and writing our code to make sure that it always works with specific XML. We can just assume that everything is working nicely with JSON. And so Python can consume this nicely, PHP can consume this nicely, Node.js can consume this nicely, and in JavaScript, which is what Node.js is built on, this is basically just a standard object. No big deal. We've already learned about all of these pieces. It's just, it doesn't have a variable. That's all it is. It's just plain text with a bunch of object data in it. And that is JSON. So when people say, oh, JSON is big and complex, they're wrong. It's not. It is literally just a JavaScript object. It just doesn't have a variable name. That's all it is. And so the idea here is that if I have this object, I can expose it on my web server and another server can consume it, or JavaScript on someone's computer can consume it. And so we're going to be using this in our final project. At this point in time, there's nothing to do. We're going to get some hands-on experience with this in our project, but really, you just need to know that JSON is literally a JavaScript object. That's all it is. Let's talk about Ajax. Actually, it's not all caps anymore. It's just called Ajax. And so Ajax stands for asynchronous. Make sure I don't typo that. I'm not even sure if I did or didn't. JavaScript and XML. And so Ajax itself is actually not a programming language. Ajax is a combination of a browser's built-in XML HTTP request. So I'm saying XML HTTP request object. And that is the simplest way that your browser can send data to a server and accept data from a server. And so whenever you like a post, or whenever you like a photo on Instagram, or whenever you tweet something, or you're on Twitter and it automatically reloads your tweets for you, or you scroll down on Instagram and it just keeps on loading more and more images, that is an Ajax request. And so basically you can send this tiny amount of data to a server asking for more data. And that server can then send back usually a JSON object, which is what we learned about in the last lesson. And then JavaScript can parse that data, turn it into JavaScript objects or JavaScript arrays, and loop through the data in there and add more to your document object model, add more HTML to your page dynamically. And that is powerful because now you don't need to reload your page. You don't need to click load more and wait for the page to load. You don't need to go to page 2 or page 3. You can just keep scrolling and it'll just keep loading more and more data for you, assuming there's data to load, that is. Now the nice thing is it's super lightweight, super lightweight. And that's because it only needs to send a tiny bit of data and only needs to accept a tiny bit of data. So when you make a standard web request, your browser is going to go to www.facebook.com and it's going to ask for all sorts of things. It's going to ask for a CSS file, it's going to ask for HTML, it's going to ask for JavaScript, it's going to ask for images, it's going to ask for all sorts of endless things. With an Ajax request, it is simply sending a small little request and saying, hey, psst, Facebook, can I have just a little bit more information? And then Facebook says, yeah, okay, you can have some more information through their API. And they send back JSON, or Instagram will send back JSON, or really most APIs these days will send back JSON. And instead of sending back CSS files, which you've already loaded, or HTML, which you can write dynamically with JavaScript, or even loading more JavaScript because it's already been loaded once, it can literally just send you the JSON data, just raw data. It doesn't need to give you all that extra stuff. And so it loads super fast. So we used to use these things called XML HTTP request objects to make these types of Ajax requests. But nowadays, we don't need to do that. We don't need to do that. We can just ignore that. And instead, we're going to use this thing called the fetch API, which makes it significantly easier. There's no try-catch involved, which we used to have to write. We don't have to worry about dealing with Internet Explorer. We can just straight up use fetch. And that is the function that we're going to get into in the next lesson. All right, in the last 2 lessons, we learned about JSON and we learned about the fetch API and what Ajax is. And in this lesson, we're going to actually write a little bit of Ajax and we're going to get some information from a website. So we're going to use the fetch API, and that's because it's the new way of making Ajax requests. It handles things for us so that we don't need to, which is really nice. We don't have to write as much code, basically, and less code is always more. That's why we're not learning the old way of Ajax requests. It's old, it's outdated. We don't need to do it anymore. Instead, we're going to be learning fetch. So with fetch, it looks a lot like this. Fetch HTTP website.com does something, then does some more stuff in here, then does some more stuff in here. That's really all there is to a fetch request. And so we're saying, go and get information from website.com. Now we're going to use a proper example here, but this is what the syntax looks like. And you'll notice that I'm using an indent here because I don't necessarily want it to look like this. This looks a little harder to read. And because it's actually the then keyword or the then method is part of the fetch function, I'm going to indent it so it looks nicer so that I know when I'm reading fetch, the next line when it's indented is also part of this fetch. So what I'm going to do is I'm just going to open up my browser and I'm going to go to swappy.dev. And this is where we can get some Star Wars information, just an API for Star Wars. There's another one, if you don't like Star Wars, you can do Pokemon API. And this is pokeapi.co. It's pretty much the exact same thing, slightly different URLs, but will give you very, very similar data. So if you're feeling like you'd rather do Pokemon stuff than Star Wars stuff, just swap out swappy.dev for pokeapi.co. The data is going to be slightly different. It's going to be structured slightly different. So you're going to have to handle that on your own, which is a good upgrade project, by the way. But for now, we're going to be using swappy.dev. And the idea here is that we can simply type in swappy.dev/API/planets/3, and that's going to give us Yavin 4, or people/1, and this is going to give us Luke Skywalker. And so we can actually go to this URL, and let's do this, API/people/1. And you can see it's giving us all sorts of information. Oh, there's links in here that we can't really see, but it's giving us all sorts of information. And if you take a look at this, doesn't this look a lot like JSON? Interesting, because it is JSON. And isn't it interesting that it already looks like a JavaScript object? That's amazing. We've got arrays in here. We've got an empty array. We've got regular strings. We have mass and height, which honestly should be numbers, but they are coming in as strings as well, which is totally fine. We can work with that. We know how to cast a string to a number and work with that as well. So we want to use this URL and get some information about our friend Luke Skywalker. So what I can do here is fetch, and I'm just going to paste that URL in here. Then I'm going to take that response and I'm going to JSONify it. So response.json, and this is using arrow functions. We're familiar with these already. This is a short way of writing a one-line arrow function. Then we can take that response, and we can call it anything we want at this point. Let's just call it data. And let's go ahead and use a regular arrow function here and do console.log data. Now let's go back to our primary document, and let's just refresh our console here. And you can see it takes a second to kick in there. It's not as fast as it usually is, and that's because it's asking another server for information. But it is still pretty fast. And so we now have this object in here that has the birth year, eye color, hair color, name, starships, vehicles, it even has all the films that he's in, which are more API links, which we could go and get information from. This is how we make a simple fetch request. So what I would like you to do is create a simple fetch request. Now you can use the Star Wars API, or you can use the Pokemon API, or you can use really any other API as long as you have access to that JSON. And just remember, we're going to fetch that URL. We're then going to take that response and turn it into JSON with response.json. Then we're going to take that data, which is basically the response.json. We're going to take that data and we're going to console log that data. And that's all we're going to do at this point in time. Once you have that console logging in your console, let's head on over to our final project, where we create a way for our page to randomly load a character from swappy.dev. And this is going to be our final project. So make sure you have a few minutes lined up. Make sure you've got probably 20 to 30 minutes lined up for this project. Once you have that, once you've got a cup of tea or a cup of coffee, let's work through this project together. Welcome to your final project. Your project here is to create a page that randomly selects a Star Wars or Pokemon character and displays some of their information. Okay, it's going to need to get random character information. So you're going to need a button that says like randomize or get new character. And so you're going to need an event listener for that. You need an event listener for some sort of button. So when you click a button, it's going to fetch more data. And you should already know about event listeners from JavaScript 101 because it's super common. It's just part of JavaScript. It's actually the main part of JavaScript. It's what makes JavaScript interactive. But if you don't know about event listeners, quickly go and do a little research because you're going to need it for this project. So every time a button is clicked, you're going to need to use the fetch API and go to swappy.dev or pokeapi.co. You're going to need to pull a bunch of information. And remember, you're going to need to use .then. And you're probably going to need to use it twice. .then. And then I want you to grab whatever JSON they're giving you. And once it's parsed in your JavaScript, change the body in here. So change like the name, you could add planet, you could add the movies that people are in, things like that. And so I want you to give this a shot. Okay, I'm purposely not giving you a lot of direction here because you need to figure these things out on your own, which I know is a little bit of tough love, but when you get a job as a web developer, people aren't going to be able to hold your hand all the time. So you need to be able to take vague instructions like you need some sort of button with an event listener, and you need to be able to fetch new data every single time when someone clicks that button and change things in your document object model. Now you're also going to need query selectors. You're going to need to be able to select these elements and update them. Now it doesn't need to be name, planet, movies. It could be whatever other data comes back. For instance, when we look at Luke Skywalker, we see he's got a height, mass, hair color, skin color, eye color, birth year, gender, homeworld, world, film, species, vehicle, starships, created, edited, URL, and a name. So it's pretty safe to say with this API that all people are going to have that. And so what we need to do is whenever you click that button, let's say it randomly goes to character number 42, whoever number 42 is. Or it's going to go to character 6, whoever character 6 is, and it's going to show all these different characters on your page, just one at a time. So I want you to go ahead, give that a shot, make it look like however you want it to look like, by the way. It can be nice and fun if you want to get into some CSS and make a fun generator. But go ahead and give this a shot on your own with very little direction. If you get truly stuck, you can always resume this video, and I am going to show you exactly how I do it. It's going to be very, very basic. I'm not going to get into CSS and styling and things like that. I'm just going to show you the very basic way of doing this and how I go about sort of dissecting this. Oh, one last thing I forgot. Because you need to randomly select a person, you need to use math.random. And you need to figure out how many people there actually are so you don't accidentally get a number that's too high. All right, go ahead and give that a shot. I'm going to fade out to black in just a second. I want you to pause here and try your very best. It's okay to not know all of it. It's okay to get stuck. And it's okay to resume the video and watch how I do it. But you need to give this a shot for real life experience because that's what job developers are looking for. Job developers don't want, not job developers, job employers, because employers don't care that you've watched this tutorial 2 or 3 times. They want to see that you've actually been able to write some of the code. So I'm going to fade out and fade in, and I'm going to give this a shot. Good luck, and I'll see you on the other side. All right, we need to work with the Star Wars API. And so I'm on swappy.dev, and I just want to do people. You could do planets or starships or whatever. I'm just going to do people. And the first thing we need to know here is the maximum number of people. Because if we're going to be doing a random character generator, we need to see who we can actually get. So does people / 100 actually exist? Nope, 404. What about 80? Yep, there are at least 80 characters. People, let's do 90. Let's figure this out. Nope, there's not 90. Let's do 85. Nope. 83. Yep, there's an 83rd person. Is there an 84? There's not. We know there's 83 people in this API, so our maximum number can only be 83. So let's go ahead and write that down. Let's do const random number is equal to math.random, and because we want this to be out of 83, we times it by 83. And now we want to do math.ceil, because if we do just math.random, it's going to give you a number between 0 and 1, but it's going to have a bunch of decimals. So we're just going to round that up. So if it does give us a number like 7.1, it's just going to round up to character 8, or the number 8. So we have a random number set already. Now we need to be able to go and get some information. So let's go back here, and all we need to do is if we go back to let's do character 3. R2D2, everyone's favorite. We can query this entire URL, https swappy.dev/api/people/3. And we can use fetch for that. So let's write this out. https swappy.dev/api/people/3. And we're going to hard code this for now. Then we need to take that response and we need to turn it into, well, we need to basically accept that JSON. So we need to take that response and tell our JavaScript that we're using JSON. Then we can rename it to data, and using an arrow function, we can console.log said data. And so when I come back here and just refresh my page, we get a bunch of information here. And this gives us R2D2. That's exactly who we were looking for. And in fact, if I go over to network, you can see that if I'm doing XHR, XML HTTP request and fetch. If I click on this, it's going to give us all of this data, and we just JSONified it and turned it into a JavaScript object, which we then console log. And now we have access to all of this. We can do console.log data.mass 32, whatever his weight is, 32, we could say kilograms or pounds or whatever. And so what I'm going to do here is I'm going to change this to character instead of data, because data is a little vague. We know this is character information. So now when I load the page, it's always going to get character 3. Let's go ahead and change this so it gets a different character every time. And let's change this to a template literal and get rid of that number 3. And we want random number. And so every time we load the page now, it's going to go to swappy.dev/API/people, random number between 1 and 83. So save that, and let's go ahead and refresh. Character is not defined. You're right, because I spelt it funny. If you're screaming at your screen saying, Caleb, you made a typo. Yeah, typos happen. Let's refresh. Name, Dorme. Let's go ahead and refresh again. Bale Prester Organa, Bale Organa, Jar Jar Binks, Wedge, Kit, Bosk, Chewbacca, Sebulba, Qui-Gon Jinn, Ramus, Leia. We're getting all of these different people every time we refresh the page. Now, that's pretty cool. That's basically what we want, but that's not quite good enough. That was not the project. The project was click a button to make that happen. So what I'm going to do here is just reattach this, and I'm going to add some data to my document object model. So I want to be able to change the name, for instance. Name. What other data do we get? What information do we want? We've got the name, skin color, species, homeworld, gender. Let's do eye color, and let's do birth year. Eye color, and let's do birth year. And so by default, nothing's going to show up in here. We need a button now. Button dot get random character. Randomize. Okay. Currently does nothing. But we can select this and we can create an event listener around it. So we can say document.query selector. We're not using query selector all because there's only one. We're going to get this by the class name dot add event listener. And what happens when we click it? We're going to give this an arrow function. And in fact, this is getting way too long. So let's make this a little more readable. Button, and let's do const button is equal to. And so whenever that button is clicked, we pass in the event, and let's also close that properly. And let's do e.prevent default. And all that's going to do is, if this is part of a form, it's not going to submit the form. It's not going to refresh your page for you. Now let's do console.log clicked. And whenever we click this, we can see it says clicked at the bottom there. Now that's doing exactly what we want it to do. Let's go ahead and grab this code and just move it up a couple of lines. And so every time we click, it's going to get a brand new random number between 1 and 83. It's going to then fetch that character, whoever that person is. It's going to then take that response, understand that it's JSON. It's going to then use that response, the JSONified response, or that object response rather, and use a character. So let's go ahead and refresh this. Nothing happens, but when I click randomize, it just got Barris Offie, Leia Organa. And so every time I click, it's getting someone new. Now we just need to make sure that this shows up in here. So what we can do, because we only really need to grab these once, we can do const name, and this is going to be a node. And we can do document.get element by ID name. And we can copy that over a couple of times and take the shortcut here. Eye color and birth year. Nope, not birthday. Birth year. And so now we have a bunch of consts in here. And we've got a button. Whenever that button is clicked, go and fetch new information. Let's go ahead and populate this information now. Let's do name dot inner HTML is equal to, and I'll just scoot that up. And we need the character information. So we have that console logged in here. And I'll scoot that up. And the name is just name. So we can do character name. We also have eye color. Eye color, and we're selecting this one up here. And eye color is eye underscore color. Eye underscore color. And the last one is birth year. And birth year is birth underscore year, unknown. So birth year. Let's get rid of that console log. And let's save and refresh. Let's hit randomize. Look at that. We have some information coming in now. Every time we click randomize. So basically at this point we're done. We can just make this a lot nicer. So if we wanted to, we could say something like strong name, birth year. And let's put some default in here as well. Let's do dot, 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 and dot, dot, dot. There we go. Look at this. That's working quite nicely. Now, if we wanted to, we could try and look up some sort of image from somewhere. And if you want to take this one step further, you can always go to this URL. And this has all the same character data, but it has an image for, I think, everybody. So you can then make an API request to this URL and get the image. You're going to have to match that ID because this is all of them. And I'm purposely giving you the harder one here. There is information for just one character at a time, but you can have all of them in here as well. You can even fetch this at the very beginning of the page and just sort through them. This way you only have to make one fetch request for all of this data, and you don't have to do it every time you click the randomize button. And so this will go and get an image, and you can add an image to your page if you wanted to as well, for a little extra bonus credit. Now, what I like to do is whenever I click randomize, there's always that little bit of a delay. And because I'm a little old school, I don't really like knowing that things aren't happening. I want to see, as soon as I click something, I want to see that it's doing something. So what we can say here is on every click, we can take the name, eye color, and birth year HTML, and I just copied and pasted that in here, and we can change that to loading. So I'm going to select all of these, move that over, and it's just going to say em loading /em. And so whenever I click that randomize button, it's going to not do anything. And then it's going to change that inner HTML of the name, eye color, and birth year elements up here. It's going to change it so it has the word loading in there and it's italicized. And then it's going to go and make that request. Now, if this request takes 5 seconds, at least someone knows that it's working. So let's go ahead and refresh and watch this. You can see that it's actually loading. And it's working perfectly. And this is all we want to do at this point. This is our final project. Now, as a student of mine, what I would like you to do is I want you to take all of your code and I want you to either take a screenshot of it or share it using like codepen.io. And I want you to take a screenshot of your final page here, whatever it looks like, even if it's just bare bones like this. I want you to be able to share your source code. So you can even put it on Git if you know Git. But if you don't know Git, you can use codepen.io. Just to share all of your code and share it in the Learning to Code Facebook channel and ask for feedback. There's always ways we can improve our code. My way is probably not the most efficient way, but it's also certainly by far not the worst way. So it's pretty good. But there's probably other ways that you could do this that other people would have opinions about. And it's good to have those opinions exposed to you when you ask for feedback. So please share your project with the community.